Hello everyone. In today's video, we will look into the topic of logarithms and aim to gain a clear understanding of the various formulas associated with them. I have observed that the mathematical notation of logarithms often intimidates students, causing them to shy away from understanding its true meaning. So let's begin by examining the concept of logarithms with a very simple example. Imagine you are walking through a dense forest and you come across a mysterious well. This is not an ordinary well as it possesses magical powers. In front of the well, you find two magical coins, a silver coin and a gold coin. When you drop the silver coin into the well and recite the magic word abracadabra, it transforms into two silver coins. When you say it again, the two coins turn into 4 coins. Each time you repeat the incantation, the coin count doubles again. Can you tell me how many times do you have to recite the spell in order to transform a single silver coin into 16 silver coins? Pause the video here if you want some time to think. Let's examine the progression. The first time the spell is cast, the coin count goes from 1 to 2. The second time the count goes from 2 to 4. The third time count goes from 4 to 8. And finally the fourth time count goes from 8 to 16. Therefore, the magic word must be recited 4 times in order to turn one coin into 16 coins. Congratulations! You have successfully solved the first logarithm problem. I'm not joking. The logarithm is simply a mathematical notation to write the question that I asked you. The same question can be written in mathematics like this: log of 16 to the base 2. Here 16 is the number of coins we wish to get at the end. The base of the logarithm, which in this case is number 2, is the rate of growth that we achieve with each magic word. And 4 is the answer since we had to chant the magic word 4 times to turn one coin into 16 coins. In other words, logarithm asks the question, how many growths of 2 are hidden inside number 16? Remember the gold coin lying in front of the well? This coin has even stronger magical properties. When you drop the gold coin into the well and recite the magic word abracadabra, that one gold coin transforms into 10 gold coins. When you say it again, the 10 coins turn into 100 coins. Each time you repeat the incantation, the number of coins grows tenfold. If we say it the third time, the 100 coins would transform into 1000 coins. The same fact can be written using logarithms like this: log of 1000 to the base 10 is equal to 3. Notice that the base of the logarithm is 10 this time, since we are talking about the gold coin, which grows 10 times when we chant the magic word. With this coin analogy, it becomes easier to understand the different properties and formulas of logarithms. Can you tell me how much is log of 1 to the base 2? Let's convert this math notation to our language of coins to understand it better. How many times do you have to cast the spell to transform a single silver coin into a single silver coin? In other words, how many 2's do you have to put on the right side of this equation to make it true? Oh, we already have the number of coins we wish to have. This means we don't have to say the magic word at all. So the answer to the question is 0. Log of 1 to the base 2 is 0. Even if we start with a single gold coin and need a single gold coin at the end, we will need to chant the magic word 0 times. So log of 1 to the base 10 is also 0. We don't have to restrict ourselves with only silver or gold coins here. In other words, we can have growth rates other than 2 or 10. In fact, it doesn't matter what the growth rate is. If we start with a single coin and don't need any growth, then the answer to how many spells is always 0. This means whatever might be the base of the logarithm of 1 is always 0. Let's consider another property of logarithm. Log of b raised to n to the base b. Don't worry, we can simplify it. This equation represents the logarithm of the result obtained by multiplying b n times. The logarithm is asking how many cycles of growth by b are needed to reach the desired result. We can see that there are n instances of b in this expression. Therefore, to reach this result, we would have to chant the magic spell n times. So the answer to the equation is log of b raised to n to the base b is n. With this analogy for logarithms, it becomes easier and more intuitive to understand certain logarithmic laws. For example, the product law of logarithm states that the logarithm of a product of two numbers is equal to the sum of the logarithms of the individual numbers. Don't be intimidated by the mathematical notation. The concept can be explained through the coin example. Suppose you have to turn a single silver coin into 512 coins. Notice that 512 can be expressed as 32 times 16. To turn one coin into 32 coins, you need to chant the magic word 5 times. Then by chanting the spell 4 more times, each one of these 32 coins transform into 16 coins. In this rectangle formed by coins, each row contains 32 coins and each column contains 16 coins. Thus we have total 32 times 16 or 512 coins. So to transform a single coin into 512 coins, we had to chant the spell total 9 times. First 5 times for 32 coins and then 4 times for 16 coins. And this is what the product law of logarithms is trying to tell us. In this video, we will not cover all the logarithmic identities in detail, as that is not the main objective. The goal of this video is to provide a method for thinking about these identities intuitively so you can better understand them. I hope this approach to logarithms will be helpful when solving related problems. I have covered some of the basics of logarithms in this video. If you would like to see more advanced content, then please like this video. Your feedback in the forms of likes or comments is highly valued and important to me. Before I conclude, I have a fun puzzle for you. Let's see how many of you can solve it. Imagine that I drop a single silver coin into the well and recite the magic word abracadabra 30 times, and it completely fills the well with silver coins. Now, if you were to repeat this experiment from the start, can you guess how many times you would need to recite the spell to fill exactly half of the well? Please leave your answers in the comments below. Don't forget to like the video and subscribe to the channel. I'll see you in the next video with another interesting topic. Until then, goodbye.